Hello and welcome to my YouTube channel SARAL GYAN. So today in this video we are going to discuss about time complexity and what are the steps by which we can measure the time complexity of an algorithm. So first of all we need to understand what is the meaning of time complexity. In general it is how much time a particular algorithm is taking in its execution. Generally we measure this time complexity of an algorithm by the method which is known as a frequency count method. That means how many times the statement which we mention in the algorithms are being executed. So every time a particular statement will consume or will take a unit time for its execution. So as the number of statements will increase in an algorithm, we can say yes, this algorithm will take more time in execution. So ultimately we will measure the complexity, especially time complexity, by analyzing the frequency of the statements. Let us consider one example where algorithm A is having more number of statements and algorithm B is having less number of statements in order to solve this single problem, is in order to solve a common problem. So since number of statements are more in A in comparison to B, then we can say it is having, there is more frequency of statements, and hence uh, algorithm A is having more time complexity in comparison with algorithm B. So once an algorithm is having more time complexity, that means more number of statements to be executed, that means it consume more CPU time in comparison with the second algorithm, that is algorithm B, which is having less number of statements. If the number of statements are more, then it seems to be more complex than the algorithm B, which is having less number of the statements. And likewise, when the number of statements are more, each statement needs its own CPU time. So ultimately the execution of an algorithm which is having more number of statements will be slow in comparison to the algorithm which is having less number of statements to be executed. So let us consider a very simple example in order to calculate the time complexity of an algorithm. So there is a variable x whose value will be initialized with 1, and there is one condition in the for loop x less than equal to 100, and the value of x is incremented by unit. And there is one statement which is to be executed on this condition. So now we need to test how many times a particular statement is going to be executed. So since initialization will take place only once, therefore the value this statement x equal to 1 will execute only for one time. X less than equal to 100, it will execute for 101 time. Why this one is extra? Because up to when the value of x is 100, till then the condition will remain true. So 100 time it will execute. When the value of x become 101, then this condition x less than equal to 100 will become false. Hence this condition will be tested for 101 time. Now this increment decrement part, again it will be going to execute for 100 times. So maximum time taken by this statement will be 101 units of the time. This print x will execute till the condition of the loop remains true. So this statement is going to execute for 100 times. So 100 unit of the time it will also take. So if you make the total of it, the total time taken by the algorithm is 101 plus 100 equal to 201 units of the time. So if you make certain changes in our previous example, instead of 100 we replace the value of 100 by n. So let's see what kind of impact it will give, because the value of n is now unknown. It may be any number. So again the value, the initialization will take place only once, x less than equal to n. Previously it was when the value of n was 100, then it this comparison takes place for 100 plus 1 time. So now since the value of 100 is been replaced by n, therefore it will take n plus 1 comparison, means it will going to be execute for n plus 1 time, and this increment is again going to be for n times. So overall the time taken by this for statement is n plus 1 units of the time. So whatever written inside the loop body is going to be execute for n times. Hence this print statement will take n unit of the time. So if you make the total of it, it it gives you n plus 1 plus n, that is 2n plus 1 units of the time. Uh, s- uh, since this time is a function of n, that's why we represent, therefore we represent the time complexity as a function of n, fn. One more important point here is in algorithm we consider only highest power of polynomial term. Therefore, in this fn, when the value of fn is 2n plus 1 here, so the highest polynomial term is n. We ignore the constants in order to make the complexity analysis simple. So we can say this algorithm will having the complexity in order of n. So let us consider another example which we use for matrix addition. Matrix addition will undergo the uses of nested loops. We directly come to the time complexity analysis. This for loop is going to execute for n plus 1 time, hence it will consume n plus 1 units of the time, we have seen previously also. So whatever written inside this for loop, means all the statements of this for loop are going to execute for n times. Coming to the next for loop, this is again a for loop. So if it is a loop, then it has to be executed, or it will execute for n plus 1 time. So this n is going to be multiplied with n plus 1, because n time it will execute for upper loop, and it itself executes for n plus 1 time. So total number of time this for loop, inner for loop, will execute is n square plus n time. So when this for loop will execute for n plus 1 time, whatever written inside this for loop is going to execute for again n times. Hence this Cij equals to Aij plus Bij, this statement is going to execute for n into n, that is n square time. So if we count that, if we calculate the total time complexity, so for this matrix addition, it is equal to 2n square plus 2n plus 1. And since we consider only the highest polynomial term, therefore we can say the time complexity for matrix addition is in order of n square. So let us consider another example which is related with matrix multiplication. So matrix multiplication undergoes the use of nested loops again. So this outermost loop will execute for n plus 1 time. So all the statements of this loop body, of its loop body, are going to execute for n time. So we can directly write n. Coming to the next statement, which is the middle for loop. This loop again going to execute for n plus 1 time. Therefore, all the statements of middle loop body are again going to be execute for n time. Coming to the next statement, which is again a for loop. This for loop again take n plus 1 time. So the last statement Cij equals to Cij plus Aik into Bkj is again going to execute for n time. So if we calculate the total time complexity, it is going to become equal to 2n cube plus 3n square plus 2n plus 1. And again we consider only since the highest polynomial term, therefore we can say the matrix multiplication is having the time complexity in order of n cube. Thank you for watching this video.